I got a 2006 Honda Accord here that they brought in today. The customer's concern is that the air conditioning doesn't work. They've had it to numerous other shops. Seems to be an electrical problem, I'm told. Got a couple new parts hung on it, and I found some interesting wiring going on here. Not really sure what's going on. Can you hand me that light that's on the driver's floorboard right there? I got the air conditioning on right now, and my fans look like they're running at low speed. I'm not sure if the camera's picking that up or not. But my compressor, you can see it way down yonder. See if I can get a better angle. That's a little better. My compressor clutch is not spinning. Now I went ahead and pulled the refrigerant static charge. It's got plenty of refrigerant in it. It's just not functioning right now. So we went ahead and pulled the wiring diagram here for the AC system. Figured it'd be a good place to start. And I wanted to, not sure if that's coming up real clear there. I wanted to find a way to split the system. That's how I usually do my electrical diagnostics, but I figured before I got too deep into that, I wanted to make sure I knew how the system works. So. Alright, so this system, you see that right there? This system, our main culprit, that's our AC compressor clutch right there. Of course, we got a constant ground, which I got a good ground there. And then I should get power on this pin 1 light blue wire at the AC compressor from this underhood fuse box, which is where the relay is located. So I figured that would be a good place to start, but even before that, I wanted to make sure I knew how the system works. Now this system, like most other vehicles, watch out, Shirley, sorry. Try to get this here. This is got the all-tail scanner hooked up to it. Getting a bad glare. Get that door shut and see if I can't get the glare out of this thing. So we're going to go in. I want to make sure that the PCM is actually commanding the compressor clutch on before I go anywhere. See the PCM right here, excuse me, right here, let's do that. Relay control comes out of the powertrain control module, goes up through this under dash fuse box, and sends a ground to the AC compressor clutch relay, which has constant power coming from this under dash fuse box right here. Make sure you see that. I'll probably have to edit this a little bit. So I'm going to pull this relay out and I'm going to see what I got. But before I do that, we're going to let this scanner load, and we're going to make sure the scan tool is picking up whether or not the computer is at least trying to energize it. So anything that's input related, so the control module for the dash itself, the actual HVAC control module, if it's doing its process right, it should send a signal to the ECM. ECM's then going to look at the AC pressure transducer, it's going to look at engine speed, and long story short, once it makes the calculations, it turns the AC compressor on if it's under the right circumstances. So if in the data monitor for the scan tool, if it comes up with a on or off on the PID, then we'll at least eliminate half the system. I'll know if it's an input or an output problem. So that's where we're going now. So we're going to live data. We're going to scroll through here and we're going to look for the compressor clutch PID. sure how far down it is. Alright, so we got AC switch and AC clutch. Move into the top. So right now I got an AC switch is on and AC clutch is on. Shirley, if you want to go in there and turn the AC off, we'll make sure that these PIDs right here change when she turns it off. Sorry about all that noise in the background. Hopefully you can hear me over top of it. All right, you see right now that it now shows that the AC's turned off. So Shirley, go ahead and turn it back on. Let me know when you got it on, Shirley. All right, you see it just switched. So now we have our AC switch. We know it's not an input problem to the PCM. So we're definitely looking at the output on the PCM. So if you want to walk on over here, this right here, this relay control at pin A27 of the ECM, that is what we're looking at right here. So when that switch is on, when that AC clutch request is on, I should be sending past the ground back through this ECM. So I'm going to take this AC compressor clutch relay out, and we're going to look at these 4 pins, and we're going to be able to tell a lot about that to see what's going on. So that's what we're going to do. These guys weren't so noisy. The class though, right? That's how it works. Alright, so this right here, this is the actual AC compressor clutch relay right here. And I've got, yeah, there's a zoom right up top.
Okay, make it forward or?
To the right makes it go in, left makes it go out. So if you want to take, well, they probably have it on there. Can you see these pins down here? I want to get a good shot inside here. You might want to take it off.
Look, no, I'm in there.
Can you see? Okay. You see the pins? See each one of these pins? Right
We're
here?
going to take it off because I've not seen it.
Go ahead, you can take it off.
Ow. Flip it?
Yep. Flip it and just pull it off. There you go. See these 4 pins right here? I should have a power and a ground here, which is going to activate this relay and send signal from here to here. So it's going to send power. So if I'm looking at this on the wiring diagram, this relay, these 4 terminals go to this relay. Alright. We got pin 1 and 3 is going to be here and here. One of these should be power from the underdash fuse relay box. The other one should be my ground for the relay control. And then over here I got a 7.5 amp fuse going power, that when this relay is energized, we're going to send power through here down to my AC compressor. So if I'm just doing my available voltage checks, I would expect to see 1, 2 powers and 2 grounds. So when I say that, this is a ground from the ECM.
Your light right there is blanking out your paper.
Okay.
As you're going to try it.
Can you see now?
Yeah.
I should use a pencil. Not a pencil.
Yeah, because when it goes directly on top of paper, it just it white blocks it. And you kind of lose your info.
This is our first attempt, so figured that was blinding us. So right here, this relay right here, we have 4 pins, okay? Those 4 pins are going to coincide to this relay. I should have a constant power supply going to the field coil of my relay, and then I should have a computer controlled ground. And that should happen, that should be present anytime that the scanner says the on request for the compressor, which we verified that in the scan tool. I have an on request, so my AC compressor clutch should have ground from it. And then when that happens, we're going to close this switch on the other side of the relay, and we're going to give a power supply through here to the AC compressor clutch and energizing the compressor clutch. So right now I have the relay out, and we're just going to do our available voltage checks. So I should see a 12 volt here, I should see 12 volts here, I should see ground here, and I should see some sort of path to ground back through here as well, because my circuit's not energized. I got this thing out. So I got my power probe, which makes things pretty nifty. It's just a voltmeter. So if I go over there, right at the battery, I've just connected to the positive and negative of the battery. So it measures voltage. I got 12 volts, and I got 0 volts. And then the switch allows me to give power. So right now I'm putting power out right here, and if I go that way, I'm putting ground out right here. So it's a pretty handy tool. So I'm going to go back over here, and I'm going to check and see what those 4 pins are. So I got, looks like I got battery voltage right there. This car's running, so I got 13.7 volts. I got a ground there. Looks a little shaky though. See how that's just kind of pulsing? A good ground on a power probe looks like that. That right there kind of worries me. But depending on what else is in the circuit, there may be some voltage drops across connectors. So, well, we'll just put that in our memory banks. And then I got another power supply there, and then I got a path to ground. Now, knowing these relays, the smaller pins is the low voltage side of the relay. So this is what's controlling my magnetic field. So these are these 2 wires right here. Okay? So that's my constant power, and then that's the signal that's coming from the computer to ground this relay and turn it on. Which means that this is the power that's going to the compressor clutch when the relay engages, and this is my compressor clutch. That's why I'm seeing ground path coming back. So right now, I am right here at pin number 2 of that relay for the compressor. So with the power probe, if I energize that right there, I should have the AC compressor come on. And I don't know if you picked that up. Shirley, go over to that compressor. See if you can get it and watch it when I energize it.
Okay. Now wait a minute so I can get it.
You might need a light.
Great. And you know, I can't at all. I don't know how you did it.
It's kind of hard to see.
I don't know how you did it.
It's tricky to get down in there.
No, I don't know how you did it at all. You try it.
The light that gets creepy. Alright, right there. See it? Right there. So right now, I'm going to go ahead and I'm going to energize that circuit with the power probe. So I'm going to send 12 volts down that wire to the compressor. And you see it start turning, right?
Yep.
And we know that everything from the fuse box, or from the relay, through the fuse box, back down to that AC compressor is good. I'm just not getting power, it looks like. So Shirley, you want to come back up to the fuse box? Get this out of the way. So we were here. I got power there. Now, what I could do is, I really should use that power to energize this, so I should jump across those 2. Because that way it'll at least actually tell me whether or not it's a problem on the power side of that. So I'm just jumping across the 2, and the engine's changing. I can feel it coming on. So I'm going to say that it's not a power supply on that. That power is good. So we're going to go back to my little fear here. My fear here is that this ground just doesn't look good to me. I mean, it should look like that. It should be a good ground. Now, there's no load on this circuit at all. This is an open circuit, so we're just taking available voltage measurements. So I'm going to go ahead and put this relay back in place and kind of put a jumper wire in it too, so I can see what's going on. There. So be careful when you do something like that. I may have just spread those pins a little bit. Usually try to back probe wires as much as you can, but here it's just, you know, I'm not really too worried about it. I kind of snuck in on the back side and have done this a few times. So now I am in the same spot that I was, and I had a ground there, right, for that compressor clutch relay. Now I got 13 volts, so I was right here. I was right here, and I had 0 volts indicating a ground, but it was flashing, remember?
Yep.
Well, now I have the relay in place and I see 13 volts. What's happening is feeding right through there. This is pretty much an open circuit. What I'm seeing the voltage drop from this battery, excuse me, from the ground to here. So I've got in this area basically I've got like 12 volts all being used. So again, I give it ground, my AC compressor comes on and works just fine.
Something's putting power in your ground.
Right. Well, it's not putting power. What it is, let's put this back. I think we'll go in the classroom and talk now. So I will. Is it recording?
Yep.
Can you see the screen pretty good, Lily?
No.
Or it's a tiny little.
Yeah, that's what I think. It's just tiny. It's about as good as we're getting.
It's too much. Let's go with that.
Okay.
All right, so we went ahead and we pulled out our AC compressor clutch relay, which which is right here, our 4 pins. And yeah, go ahead and shut that door, Shirley. It's really loud. Cut the head of that. All right, so we basically have 4 pins. We have pin 1, pin 2, pin 3, pin 4. Let's do it this way. That was pretty bad highlighting that part. Let's pick a color. We got pin 1. Didn't change. Try that. We got pin 1. Is that showing up?
No. I would go red.
Go red.
Yes.
Red. Let's try it. So pin 1.
Yep.
Pin 2, pin 3, and pin 4. So we got 1 and 3 are our control circuit for the relay itself. We saw here with the relay unplugged 0 volts, which is what we should see for ground. But when we plugged the relay in and tested it with the relay trying to energize, we saw 12 volts. Out of 13 and a half, well, it's running roughly 1.5 volts that the relay is actually using. So that's not enough to energize a relay, not enough at all. So we went ahead and we gave a path to ground using my power probe, and the AC compressor worked just fine. So we're not concerned with anything on this side of the circuit, are we?
No.
We know everything there is good. But we're concerned about, oops, too far. We're concerned about this circuit right here. And it's really just a simple circuit. Keep making that go away. So we know that I have 12 volts. And when I say 12 volts, we're just going to say 12 volts means battery voltage. If the car is running 13 and a half, 14, 12 is good. Here, we didn't. All right, here we saw 12 volts when we were trying to energize, when the relay should have been energized, and we should see 0 volts there.
Right, it should have been used.
So my problem lies somewhere in this area. So we've narrowed down 3/4 of this system, haven't we? We know everything on this side is good. All this is good. What we don't know is, right here, right there. That's what we got to go after.
Yeah, I would start with the fuse box under the dash.
Go there.
Yep.
And we definitely have. Looks like we got 2 connectors here. We got connector D. Honda does this. The D is the connector in the connector number, I should say, and then 5 is the pin. So we got a connector D, pin 5, and a connector X, pin 9. And this is just a pass-through, isn't it? This isn't a fuse or anything. I mean, if it were a fuse or something, typically you'd have like a line going through it, and then whatever
Some
amperage
type of-
it is.
yeah.
So this is probably just a bus bar going through here. So we're not doing anything in this fuse box other than running continuity between these two connectors. So the ECM for this is under the center console. This is at the left front kick panel. And then of course this is the back of the fuse box itself. I'm trying to figure out what's probably easier to get to. The fuse box is probably the easiest to get to. And I think I have a wiring diagram out for that already printed.
Can we go to where the X9 is and see if
X9? Yeah, we
yeah,
could
if you
go
could go to
anywhere.
the
Really,
X9, just to see if that bar or anything ain't messed up. It's supposed to make it run through there. If we've got that bar that's kind of like, say it's like a filament in a light bulb and it's shaking, which would do that. You know what I mean?
I'm good with really going anywhere in this circle. You know, anywhere from pin or connector E, pin 15 of this. This is the underhood fuse box right here. This right here.
The bar that you're talking about is like a little metal thing, right?
Yeah, I mean, it's going to go through this module. This is actually a big module. This underdash fuse box is a big module. It's usually called, now it's called a multiplexing control unit, but it's still the same thing, and it has probably 10 connectors and 50 fuses in it.
So if we go to the X9,
Right.
we should not see voltage there, right? We should have.
I should see ground. So basically, what this circuit looks like. Hang on, I'm gonna switch back to black. Not to confuse it. So this is going to go through.
Into a ground.
Right, and there's a relay, not relay, a transistor in here that is going to
The ground, engine ground.
right allow a path of ground through this ECM. So we should see
0 volts.
0 volts there, or 1/10 of a volt. They really want to see zero voltage. If you're doing voltage checks on ground, 0 could be open as well.
Right.
I really would like to see 1/10 of a volt, you know,
Yeah, 0.01.
0.01 or 0.1, you know, something in that area. Definitely not more than a volt. 0.1, 0.2 would make me happy. If I saw 0.1 to 0.2 there, I'd be happy with that. I think these Hondas have a tendency to have bad fuse boxes. I think we'll go to this connector first because it's probably the easiest to get to.
That's under the relay, right?
Yeah, this is underneath that fuse box. It pops out pretty simple, and we'll see if I see 0 volts here. Okay, then I know that everything is good from here to here, and there are problems in my fuse box. Right. If I see 0 volts there and I see 13 here, you know, then between this pin and that pin in the box, there's a problem.
Right.
So at that point, we're going to go with a fuse box, which we might see that. It wouldn't surprise me if I did. But if I still see my 12 volts or my 13.5 volts there, then I need to go to this connector or this connector.
I would go to the X9.
Yeah, either one of those. So, yeah, let's go do that. All right, so we're looking for connector E, pin 15 of the underdash fuse box. So I printed out the connector. It looks like we're looking for a gray connector. And what did I say it was? Pin 15. So we're looking at that pin right there. So that guy right there. Which cord of this is a red wire V6 LX HVAC? Yep. So that's probably the right one. So I'm looking at this from the harness side. Honda likes to draw these from the harness side. So 16 and 15, bottom right corner is going to be a, what's that?
To light off the here.
Oops, sorry. Should be a dark, what is it? A violet purple? Violet pink, maybe? Let me get up in here. See if I can get this out a little bit more. Looking for one with 3 across the top. Not that one. across the top. That's 4 across the top. That's 3 across the top.
Should be all the way towards the bottom.
15. Could be. It's kind of hard. I thought it was this one. What's pin 7? Pin 7 is yellow. Yeah, it's yellow. So that's our red wire right there. I do believe that is it. Oh, there goes my pencil. So, can you get a shot of this connector right here? So I got the 3 empty cavities, and then I got my lock right there. I'm not sure if the camera's picking that up.
Yeah.
And I got an empty slot here and a red wire there, which 15 is red. So if I'm looking at this, 15 is red. I got pin 7 above it, top right is yellow, and then I got pin 6 is white green. And it looks like I got a yellow wire and a white green, so I'm pretty confident that that's our beast right there. Of course, the car's not on and the engine isn't running. So if you want to, Shirley, I'll hold the camera for a second. If you want to maybe go start this thing up, turn the AC on. Yeah, turn it on. Try again, a little longer. Try again. All right, come on back. Hold this. If this is the right wire, and I'm pretty sure it is, it looks like I got my battery voltage through that relay still. So I don't think it's the fuse box. I'm going to go ahead and just fire this up. I'm going to ground this with my test light, so that way, if we're on the wrong wire, we're not going to hurt anything. Show them where I'm hooking up the test light. So I got a regular incandescent test light and I hooked up to ground. Alright, so I'm going to go ahead and use this. See if I can't bring that relay on. See if it's enough. Oh, here, it might not be enough, but I'm not lighting. Let's go ahead and use power probe. Alright. Is it? 12 volts there. Not coming on. Oh, do I have a relay in? Definitely have a relay in. What's going on here? Is it coming on?
Dude, I can't see. Where's that light? I don't hear it at all.
Put the camera back on there while we work on it. Just kind of have it under the hood.
Under the hood? Mm-hmm. Let me back up. I can't make it flip it, yeah. There it was for a second.
I don't think I had. I think my pin.
Pete, what are you doing? Professional what?
Photographer, videotaper.
I think me moving this thing around, not my pin loose.
Come on. Come on.
Now we can go back down there.
Hey, let me bring this closer.
Push back up. Yeah, you wanna work that again, just bring it down here. Yeah, that's it. Alright, so back to what I was trying to accomplish. Hook this test light back up to ground. See, get my test light so you can see it lighting up. I'm going right to ground. I'm going to go over here and I'm just going to touch this and see if it's enough. You see, the AC compressor is now cycling. So that's definitely the right wire. That's what it's doing.
Make sure I get my light somewhere. Yeah, there it goes.
Doesn't look like it's in that fuse box. Just go ahead and get on the power probe. So I'm basically seeing voltage go through that field coil for the relay. So come back down here. I see voltage potential going through this right here. And I should have passed the ground. When I give it ground, this can now function all the voltage is being used, the magnetic field is being created, and I'm bringing this relay over. So
You're being the ECM.
yeah, it's definitely not. We're now good inside this box, so it's not what I thought I was going to find. I really kind of thought we were going to see a good ground there, and it was going to be in the box. So now I got to dig one of these two connectors out, which is kind of buried in there. I guess we could go right to the ECM. The ECM is probably easier to get to than these. This guy, there's a panel and the connector's in the right spot to get to. These are kind of, well, I'll show you where they're at. Actually, here. Give me the light.
Yeah, but it's running little. I can sit under that thing. I think it's an element. I think that's why
I think, Shirley, go ahead and say what you said. Say it again.
I said I think it's in the element that's just a crossbar.
You think it's in the crossbar? It could be.
It's in the crossbar.
It could be, but you know what?
And I think that's why it's showing ground one off.
I'm kind of a big chunky guy. I like to get in places I can fit first, but this is the fuse box, and the connector in question, get my camera back there, is way up top there, and kind of a pain to get to. And then if I see the same thing there, I got to go after the computer anyway. So I think instead of checking both of these connectors, because it's just an in and an output, I'm going to go right to the ECM, which is on the other side of the car and a little easier to get to.
Flip upside down.
Flip upside. Shirley wants to flip upside down. So the ECM is on this side here. But Shirley, if you want to give me those papers up there and the power probe. Turn this blower down. That way you guys can hear me. I got a huge glare there. I don't know if this is going to go all the way in. Let's try that.
And push the power with it.
It will do something.
Which one of these you need me to look?
Well, I'm going to show everybody first. So we are back down on our wiring diagram. So we are now here. That A27 connector from the PCM, that's the relay control. Sorry if I'm shaking a little bit. Get that motion stabilization going in this camera. So Shirley wanted me to go here. I think it's a lot easier to go here, and right now we're going to go straight out of the horse's mouth. We're going to see what that ECM is doing. It's connector A. You want to hold that light up there? We're looking for connector A in the PCM. This is connector A. Connector A. Terminal side of female connectors, and we're looking for pin number 27. So it is kind of glaring. Kind of just hold it like that. This side of the sheet only goes up to pin 15, so it must be on the second sheet. So we're looking for 27. 27 is a red wire for the AC clutch. So 27 looks like, according to the pin charts, try to get that in there. Kind of blocking the light on it. Pin 27 is right there, so should be a keyway there. 27. There's 5 pins bottom right. It's a gray connector on what I read, which is that bad boy right there. Can you see it? So we got 5 pins bottom right, starting with a yellow black, and then 1, 2, 3, 4, 5, and then we got the keyway cutout. Grab my power probe, use it as a pointer. So I got pin here, oops, pin there, and 5 over, there's a red one. If I go back to my chart right here, see that? Get it light your way. We got pin 31. That's where pin 31 right there. According to this, is a. Yeah, that might work. 31 is a yellow green, and that definitely looks yellow to me. Yeah, I don't know if the camera's picking up. There's a green chaser on that wire. I don't know if it's picking it up. Let's see. Green chaser on that wire right there. So I'm pretty sure that's the right connector. So we're gonna go pin 27, which is 5 wires from the bottom right corner, and it should be red. So that definitely looks like a 5 wires over. We got a red wire. 1, 2, 3, 4, 5. Try to back probe it. Car's running right now, right, Shirley?
Yes.
I see 13 volts still coming out of that. So now this is a computer. I'm not real happy with just shoving a ground into a computer with a power. I'm pretty sure. Is that picking that up? Yeah, 13.1 volts. I'm not real comfortable just shoving a straight ground into that computer. I'm going to go ahead and use the test light again, so we have a load in the circuit to be a little safer. You want to go ahead and grab the test light, Shirley?
What do you want me to do to make it reach for the ground?
Just bring it here. I got a ground in here. Nifty thing about a power probe is that the other end of this probe, about 10 inches away, about 2 feet away, there's a connector, a little alligator clip on it that is a ground. So it kind of comes in handy in situations like this. So this is now a ground. So I am going to go ahead and go over to that pin again with the test light. Try to get the camera. No, I got it. Usually lines. And did you hear? Yep, I can hear the compressor clutch cycle. Fans come on. Do it again. Yep, it's cycling. Why don't you turn the blower on a little bit? Let's see if we got cold air.
Oh, yes, it feels good.
Oh yeah. It's about 85 degrees out here today right now, so a little humid. So yep. So this computer is not sending out a good ground.
Can we disconnect that and see if something's
Well,
not...
I don't think it's going to be a pin fit on the other side. I mean, we can definitely turn it off, pull that connector out, and see if
it's something.
yeah, just to kind of see it. But you can see I got 12.9 volts. Okay, right there. So there,
that should be the ground.
yeah, that should be 0 volts. I should
Or maybe
see
a 10.
Yeah, a tenth would make me happy. 0, I might be worried about having it open. 12.9, that's pretty much battery voltage. So this is either dead open in the ECM, which we know it's not dead open because when we have the relay out, we see past the ground, just not very much. You see, it was holding it down a little bit. And as soon as I give it ground, it starts working. So go ahead and turn the car off, Shirley. And go ahead and when you get that off, go ahead and pull. I'm gonna wait. Let's just wait about a minute or so. Really should get used to disconnecting the battery every time you pull a connector, but
You want me to?
well, no, we'll just let it time down. It's not that big a deal. I just want to check the pin fit. So go ahead and pull this connector off out of there. Kind of look at the pins.
I'll have the light on this side.
I got it. There we go. Shine it on there.
Can you see?
It's hard to see. Hard to see with the naked eye, even. Not sure if you can see those pins or not. We're looking down here, this one right where my thumbnail is. Trying to see in there, and I don't see. It looks pretty good to me. I don't know if the camera's picking it up, but I don't see. It's not pressed down or egged out. There's no burn marks on it. I mean, it looks pretty clean, and the cavity looks pretty good too as well. Let's see if the camera will focus. Pull the camera right there. There you go. See, that looks pretty good too. It's this pin. Look at my
one.
This one right there. The very bottom one right there. And it looks pretty good to me. So I don't think that's it. I don't think it's a connector problem. You know, if I had the Honda makes a pretty nifty tool to actually check pin fit itself, but you know, I'm pretty confident that, you know, we got junk coming out of the PCM. So PCM's a pretty pricey part. I don't really want to just say it needs a PCM, although it definitely looks like it, because we see, you know, the computer is being told to turn on the AC compressor clutch, send that ground out, or allow that path of ground to exist, I should say, but it's not doing it, even though it says that it's doing it. When I go in there with the scanner, we've seen it say on. You know, it's definitely software-wise commanding it on. It's just that transistor, that driver inside that ECM, for whatever reason, just, you know, has voltage drop occurring. So but I'm going to check the power and grounds on this PCM just to really dot my I's and cross my T's, because I can't check everything inside the PCM itself, because I'm not an engineer. They don't give us those schematics. You know, there's a lot going on in there, but you know, the rule of thumb is that, you know, junk in, junk out. If I have bad grounds and bad powers in my powertrain control module, then any output ground or power could be in jeopardy. So I don't think we're going to see any problems. Everything else on this car works just fine. It's just this circuit. If I had a bad ground, I would expect to see multiple things not functioning, but you know, we're not in the business of guessing. We're going to go ahead and cover our bases and make sure the power and grounds on this PCM are good. So we're going to go back in the classroom. We're going to look up the wiring diagrams, the rest of the connectors, and we're going to come up with a plan of attack. Alright, so I'm not sure how well. This looks like it's picking it up pretty good.
Same as it was.
I can zoom in a little bit. We'll scroll through it. So this is my ECM, PCM power and ground distribution for V6, which is the motor that we have. And it looks like we got a total of this box right here. Let's do this one. Let's cut it. Let's do some snipping. I'll bring my snipping tool up and hit new. And we'll highlight that, because that box, that is the power and ground circuits for this PCM. So we'll put it on here. Alright, so we're everything. Oops. Can't draw. Let's try that again. Stop dragging.
You're on that. You gotta click the whole screen, yeah.
We got it. So every one of these goes to a power supply. And I think it was like IG1. These two right here were probably IG1, and this one was probably a keep alive power. But I'm not worried about where they're coming from. I just want to make sure that they're good. So I got 1, 2, 3 powers up here. These are all my 12-volt power supplies to my computer. And then I got 1, 2, 3, 4 grounds. Now, some people, a lot of people, if I go to the service manual, it's going to tell me to do resistance checks, you know, from this ground to body ground, or the engine ground, or excuse me, the battery ground. And if there's just one strand that has continuity, it's going to show good resistance. It's going to show low resistance. You know, just one strand will allow electrons to flow. But if I got amperage trying to go through it, that one strand is not going to happen. So I personally am a voltage man. I like to voltage check my grounds. So I'm going to go here, and I should see, you know, I shouldn't see 0. I should see something with a voltmeter, maybe a tenth. I may see 0 to me with a voltmeter would would kind of concern me. At that point, I may do a resistance check if I see 0. But I'd like to see a 1/10 of a volt. You know, a 1/10 of a volt to 2/10 of a volt. You know, maybe even half a volt. You know, that's probably stressing it. If I see a 1/10 of a volt, I'm pretty confident that those grounds are good. And I'm not overly concerned about my powers. I'll check them while I'm there anyway. I'll just see if I have available voltage there. If I lost one of these powers, you know, ignition input, power input, relay control, you know, this is actually the computer sending a ground. I didn't realize that when I cut it out of there. That's actually my control circuit, that MRLY relay control. This one. That's actually the computer turning its own relay on. So if I go back to that original wiring diagram.
Yeah, maybe that relay's blown.
Yeah. Well, if I did that, I wouldn't have power here, which is my main power. Oops, I can't draw on that. If this relay was bad,
Yeah.
then I wouldn't see any power here. I wouldn't be able to communicate with the scanner. If either one of these powers were bad, the car wouldn't run.
Yeah, but maybe it'll have
Yeah,
it
and
show up
we're
on the
not looking
scanner
at-
as being on.
We're more concerned about these grounds. So really, I may not even, if they're easy to get to, I'll shove a power probe in it. We'll see if it has voltage. But my main concern is these grounds. So I'm going to go and I'm going to do a voltage check. It looks like there's 2 connectors involved. Go back to the one I can draw.
They're brown with yellow tracer and black.
We got 3 wires, pins 1, 2, and 3 in connector E. And we got pin 15 in connector B. So we're going to go ahead and print out the connector view for that. We'll make all data for that. There it is. Couldn't get lucky and that'd be my connector for my ECM. So Honda likes to do it in these views. You ever get in a wire diagram that says view 259? Well, you can use that number when viewing for connector numbers. So you can see this over here in the corner. I don't know if I can see.
Yeah.
I can't just highlight that. That right there, view 259. So if I go back into all data and I look it up, I look up 259, view 251, 275. 259 should give me gives me my PCM connectors. And there's 5 of them, so I'm going to go ahead and print both of these.
Yeah, that's the E. You get 3 pins.
That's the one I had
3 pins.
3 of them. And now we got those, we can go
1, 2,
back
and
to
3 all
our-
the way at the top.
What's that?
All the way at the top, 1, 2, and 3.
That one, yep, they're pretty easy to get to. So we'll go ahead and we'll go get the old trusted voltmeter out. Actually, the power probe I'm not real comfortable with because it doesn't, I like to see that 1/10 of a volt. If I use the power probe on those grounds, it's going to show me 0. And I'm not real comfortable with 0. I want to see a little bit of voltage drop just from the connections. That tells me that I have continuity, it's not an open circuit, and then it tells me that there's no voltage drop occurring, and that's the best way to check a ground. So let's go back out to the car and see what we can figure out. So we are on DC volts. Does that help? Can you see that? So we're DC volts. This meter's got an AC. The default's the AC. Let's get a screen protector. Yeah, you can probably see a little better now. Had this meter 5-6 years, never took the protector off. So
You're glaring it with that light. Move that light.
how about now?
Yep.
Okay. So 0 volts. We're going volts DC. Let me find a good ground. I'm gonna take this alligator clip right here and shove this ground somewhere down here on the body. That looks like a pretty good ground there. We'll go back real quick. We'll just go to resistance real quick. I'll just check and see. Yeah, it looks like we got a good ground. Yep. All right, so now back to voltage. So we're checking voltage DC. And I'm going to go
You want me to go on the meter or you can go on there?
You're going to go to the meter, but first we're going to go here, okay? We're going back down to these 4 grounds we're worried about. We'll hit these connector E. There's 3 of them, pins 1, 2, and 3. Is that coming up on there? Need some light?
Yeah.
All right, so we got pins 1, 2, and 3 in connector E. Connector E is...
The other page. Just got a single one.
Connector E is a white connector. Alright, and 1, 2, and 3 are all black. Well, 1 and 2 are black, 3 is brown yellow. So I'm going to go back down in here and see if I can find that. White connector. It's the one all the way in the back. There, get it out. This one is pretty far back there, but if you see it, see those 2 black pins and then the brown yellow right there. Those are the 3 grounds that we're gonna look for voltage on. Well, I'm gonna give you the camera and I want you on the meter.
Yo, you too.
And I'll tell you what we're at. So we're going on the meter. I am checking voltage at each of those pins. Go and start the car, Pete. Say hi, Pete. Pete's another one of my students. Pete. He's the one you usually hear saying French words in the background. Alright, so we're running right now. AC's on, computer's on. We're checking computer grounds. I'm going to go to pin 3 first, which is that brown yellow. And you see how I have a little bit of voltage there? That 2 thousandths of a volt? That's a really good ground. See that? If it was open,
It'd be 0.
see how it's 0 right now? Okay, if I saw that, I might be upset. I might want to do a resistance check. That could be an open circuit. But if I'm checking voltage on a ground, you know, you saw it first when I first put it up, had about 100th. I say 1/10 of a volt, but you know, there's definitely something there. Okay, we're not talking about an open, and there may not be that much running on that one. So let's go ahead and check pin 2. This is pin 2. So we got 38 millivolts. That's definitely in spec. You know, computer ground. I'm looking for less than. You know, I really like 2/10 of a volt. Half a volt, I'd probably be okay. If that were, you know, 3 volts, 5 volts, that would be a major issue. You know, we're talking minuscule voltage. Again, good. We know that our circuit isn't open because there is some voltage drop occurring, but we also know that our voltage drop is in spec. So this is pretty powerful stuff. So we're going to go to pin 1, do the same thing. I'm on pin 1 now. I got, you know, 42 millivolts. I disconnect it. Again, that's what I would probably see if it was open. 0 volts once it stabilizes. But I'm seeing pretty good grounds. No surprise. Like I said, everything else on this car works, but we just want to cover our bases. And then I got one more ground I want to check,
Which is our connector B.
which is on the wiring diagram
Right here.
here. We're going to this ground. Can you see that, Shirley? B15, connector B, pin 15. All right. So we're going to bring this up. Connector B. Connector B is a white connector. Pin 15 is brown yellow, and it looks like it's going to be next to an empty slot, and between 6 and 23, 6 would be red and blue, and 23 would be red and black. So I'm looking for a brown yellow in between a red black and a red blue in a white connector. So we are on DC volts. Does that help? Can you see that? Mm-hmm. So we're DC volts. This meter's got an AC. The default's the AC. Let's get a screen protector. Yeah, you can probably see a little better now. Had this meter 5-6 years, never took the protector off. So
You're glaring it with that light. Move that light.
how about now?
Yep.
Okay. So 0 volts. We're going volts DC. I need to find a good ground. I'm gonna take this alligator clip right here and shove this ground somewhere down here on the body. It looks like a pretty good ground there. We'll go back real quick. I'll just go to resistance real quick. I'll just check and see. Yeah, it looks like we got a good ground. Yep. Alright, so now back to voltage. So we're checking voltage DC. And I'm gonna go.
You want me to go on the meter or you can go on there?
You're gonna go to the meter, but first we're gonna go here, okay? We're going back down to these 4 grounds we're worried about. We'll hit these connector E. There's 3 of them, pins 1, 2, and 3. Is that coming up on there? Need some light?
Yeah.
All right, so we got pins 1, 2, and 3 in connector E. Connector E is...
The other page. Just got a single one.
Connector E is a white connector. All right, and 1, 2, and 3 are all black. Well, 1 and 2 are black, 3 is brown yellow. So I'm going to go back down in here and see if I can find that. White connector. It's the one all the way in the back. There, get it. This one is pretty far back there, but if you see it, see those 2 black pins and then the brown yellow right there. Those are the 3 grounds that we're gonna look for voltage on. Well, actually I'm gonna give you the camera and I want you on the meter.
Yo, you too.
And I'll tell you what we're at. So we're going on the meter. I am checking voltage at each of those pins. Go ahead and start the car, Pete. Say hi, Pete. Pete's another one of my students. Pete, he's the one you usually hear saying French words in the background. Alright, so we're running right now. AC's on, computer's on. We're checking computer grounds. I'm going to go to pin 3 first, which is that brown yellow.
And you got...
And you see how I have a little bit of voltage there? That 2 thousandths of a volt? That's a really good ground. See that? If it was open...
It'd be 0.
See how it's 0 right now? Okay. If I saw that, I might be upset. I might want to do a resistance check. That could be an open circuit. But if I'm checking voltage on a ground, you know, you saw it first when I first put it up, had about a 100th. I say 1/10 of a volt, but you know, there's definitely something there. Okay, we're not talking about an open, and there may not be that much running on that one. So let's go ahead and check pin 2. This is pin 2. So we got 38 millivolts. That's definitely in spec. You know. Computer ground, I'm looking for less than, you know, I really like 2/10 of a volt. 1/2 a volt, I'd probably be okay. If that were, you know, 3 volts, 5 volts, that would be a major issue. You know, we're talking minuscule voltage. Again, good. We know that our circuit isn't open because there is some voltage drop occurring, but we also know that our voltage drop is in spec. So this is pretty powerful stuff. So we're going to go to pin 1, do the same thing. I'm on pin 1 now. I got, you know, 42 millivolts. I disconnect it. Again, that's what I would probably see if it was open. 0 volts once it stabilizes. But I'm seeing pretty good grounds. No surprise. Like I said, everything else on this car works, but we just want to cover our bases. And then I got one more ground I want to check.
Which is our connector B.
Which is on the wiring diagram
right
here. We're going to this ground. Can you see that, Shirley? B15, connector B, pin 15. All right. So we're going to bring this up. Connector B. Connector B is a white connector. Pin 15 is brown yellow, and it looks like it's going to be next to an empty slot. And between 6 and 23, 6 would be red and blue, and 23 would be red and black. So I'm looking for a brown yellow in between a red black and a red blue in a white connector. Yeah, go ahead and fire it up, Shirley.
I got
So I found it. If you want to go ahead and give me that, give me that. I'll show on the wire. I don't know if you guys can see it or not, but it is. See, I have a red and a blue. They're coming up good there. I need that light to move. That's probably better. That glare. Alright, you can kind of see it. It's kind of in a bad spot, but you see my little pointer right here, my test probe. I got a red and a blue one here above a tan and a yellow one. That tan and the yellow one is the one I want. If you want to go back on the voltmeter now, Shirley. So
You were dropping it while you were trying to look at the size of the phone under there.
that doesn't surprise me. They get the gist of it. So right now I'm not hooked up to anything.
Yeah, I see.
I got 0 volts, right? So I'm gonna go ahead and go on that wire there, the tan yellow pin 15, and I got a little something there, 4 millivolts. Not a whole lot, but it's enough to let me know that it's not open. It's, again, disconnected. Let it stabilize. I got nothing, right? Might be a little bit in the air, you know. Not a whole lot though. Almost 0. Definitely got a little something there. You know, 4 millivolts. I'm happy with that. There's no voltage drop on this. I think we're calling an ECM. Like I said, I could go a step further and hit these powers, but I mean this ECM works. I mean this car runs. There's no real reason for me to check these powers. You know, there's really only 2. This right here is a relay control in itself, so it's going to ground it out. Oh, I know what I wanted to show you. I wanted to show you. What am I looking for right here? I'm looking for a ground, right?
Right.
All right, and I saw 13 volts there. Am I just voltage checking a ground? Am I not doing the exact same thing I just did with my ECM grounds?
Right.
So that's why I saw 13 volts here. I have a bad ground. If I had a bad ground at the ECM, I'd see the same scenario. I would see, you know, 12 volts on one of those grounds if it was causing it. Beyond a shadow of a doubt, it's in that computer itself, all right? Without a doubt, it's in that computer.
Could be the relay inside the computer.
It's a transistor, but yeah, just like a relay. If these grounds were the culprit, I saw my 13 volt drop on one of those grounds,
Yep.
and I don't see it. So beyond a shadow of a doubt, this thing needs a computer. The scanner PID says that the ECM is requesting compressor clutch. It says on in the scanner.
But
so
it's
all
not.
my inputs to the computer are good. All right, that means the computer is now saying, hey, turn my AC compressor on. I do not have a ground coming out of the ECM, and I've checked my grounds going to the PCM. The only thing this thing can need is a PCM at this point.
Are we done?
Yep, we're done.